Welcome to Chibuzor Mathphysics. In today's video, we are dealing with the Lagrange's interpolation formula. Welcome to Chibuzor Mathphysics. In today's video, we are going to be using the Lagrange's interpolation formula to find x at 10 from the table. So let us have our table. We have the value of x, and then we've got the value for y. So for x, we've got 5, 6, 9, and 11. 5, 6, 9, and 11. For y, we have 12, we have 13. We have 14 and then 16. So this is our table. So the first thing to note is that this table is unequal. So we've got unequal intervals in the 1, 2, 3, 4 times. So our formula is going to be up to 4. And for the purpose of how we got the formula, I will refer you to the previous video where I derived the formula of Lagrange's interpolation. So let us have our formula. You might need to note that we are going to use x0, x1, x2, and x3 since we are having 4 terms. So our x0 will be given by x0 will not be among inside this, so it will be x minus x1. Then we have x minus x2, then x minus x3. Divide this by x0 minus. So the final one, since we are having 4 terms here, will be, this is x3. So for x3 we skip x3 so that we have x minus x0, x minus x1, then x minus x2. If we are to have more than 4 these values, we can have x minus x4 instead of x3 because we are skipping x3. So divide this by x3 minus x0, x3 minus x1, and then x3 minus x2, x3 minus x2. Of course, we know that we multiply this by y3, just like here we multiply by y1. This is y0 and this is y2. So we need to now plug in the values in this given formula in order to find x at 10, because we are told that x is at 10. So let us continue to do that. So the first thing we need to do now is to plug in our values in the given formula. When So directly we are going to substitute these values in the given formula. So we need to start with x0. We know that in the x0, this is our x0. Let's have that down. This is x0, this is x1, this is x2, and this is x3. So we substitute this in this given equation in the formula that we have. So our x minus x1 is we are given x to be 10, so it is simply 10 minus x1 is 6, so it is 10 minus 6 into our x minus x2 is 10 minus x2 is 9. Then we have x minus 11, which is 10 minus 11, because it is x minus x3. Divide this by x1 minus x1, that is x0 minus x1. This is x0 minus x1, and x0 is 5, so it is 5 minus x1 is 6. 5 minus 9, then we have 5 minus 11. So we multiply this by y0, and our y0 is 12, so multiply this by 12. Plus, we do the same to this given equation. X minus x0 is simply 10 minus x0 is 5. So the third one will give us this is x minus x0, that will be 10 minus 5, so we have 10 minus 5 into 10 minus 6, 10 minus 6, then we have 10 minus 11, divide this by 9 minus 5, this is 9 minus 5 into, we have 9 minus 6, then minus 11, 9 minus 11. Of course, multiplied by y2, and our y2 here is 14. Here we have got 13, y1, 12 was y0, so this is now our y2, which is 14 multiplied by 14, plus the last is this formula. Let's plug into that. It is that will be 10 minus 5, 10 minus 6, 10 minus 6, then 10 minus 9, 10 minus 9. Divide this by x3 minus x0. x3 here is 11, x0 is 5, so it is going to be 11 minus 5, 11 minus 5, multiply by 11 minus, then we have 11 minus 9, so this is 11 minus 9. Of course, we multiply this value by, we multiply x3 multiply by y3, and y3 is 16. y3 is 16. So simply plug in this into your calculator and find the final solution. Let us do that, and if you do that, you will have 44.6666, and this will be the solution of x at 10. So x at 10 is equal to 44.6666, and this is how we use the Lagrange's interpolation formula to find some certain values when we have an unequal intervals. Hope you have enjoyed the video. In the next video, we will continue with the Nelson interpolation method, and we will use dissections and other numerical method for computation. I remain your friend Augustine Galagash. Kindly subscribe to this channel.